So presenting my Sensing and Internet of Things coursework. So we've got a Raspberry Pi set up with an MQ2 sensor doing gas readings. We've got an ADC converter and a logic level converter. I've got a Philips Hue light, which is going to actuate depending on the gas. We then have a dashboard as well, which is giving us relatively live readings of the gas, and we're pairing that with an open weather API, which we've collected over the last week, coming on through. So I'm now going to release some gas and we'll see what happens. So as you can see, I've released some gas and we've now got the light has gone red, and we're going to get something a shot coming through here on the dashboard as well. So this is all being pushed up to the cloud, or the data, and then it's being pulled back down in a Python script, and then here again in the dashboard as well. And the gas is now gone, so the light has changed back to its default color. And as you can see, we've got a spike coming through on these readings. And a little bit earlier, there was different weather. So it was above 10 degrees centigrade, and so we had a green light here, and everything is fine. There's no smoke at that point, and it was a little bit cooler, 9.5 centigrade, and the light is blue. So the idea is that this is like an early warning system, quite useful for users. And then we've got this dashboard that sits with this, which is more insightful. You can kind of get granular data here, and the idea is that this is fitting into an insurance company, so it's a kind of pre-warning system for sort of preventative. So we basically don't want claims being paid out when there's a smoke reading. Basically don't want to fire at all, don't want to pay out. Pairing that with weather, so the idea being, is there a correlation between your weather, so when you might be colder, you might have a fire on, you might be lighting candles, and the chances of there being smoke. It's a fully responsive website being run on WordPress, and we're using business intelligence powered by MongoDB, which is where we're hosting all of the data. So how is that all working? So we've got an open weather API running on MongoDB Atlas, which is an Amazon Web Services hosted NoSQL database, and we're ingesting that data into the database using a GET and a POST request. And the way we've set that up is that there's an if this then that applet, which is running in the cloud on their platform. So basically the open weather API stuff doesn't require a Raspberry Pi or anything. It's all running remotely in a server, which means it's pretty scalable. Anyone can do this. You can access it, and there's a post request happening there. So you can actually use this applet yourself, made it open source, and I'm now going to actually turn that off so that the data that you're seeing is basically up until this point. And that is triggering the weather every hour. So let's have a look at the database. So we have gas readings coming through from the Raspberry Pi, which is being pushed up to the database, and we have these weather observations. So this is a NoSQL database on MongoDB, so we're getting the full richness of the data that's being provided to us by the API, which means even if we discover a future application, we've got all of that data there, and that's accessible, and that NoSQL bit means it's quite good for web applications as well. So we have a smoke Python script, which is running on the Raspberry Pi using Cron, so it's running all the time, and that's pushing things up to the database. With that, there's some more scripting about kind of pre-processing the data from the signal. So there's a calibration phase where this detector is actually calibrated, and we say, okay, now make sure that these readings are correct, and we're going to constantly push that up. Then looking at the Philips Hue side, so we've got this light which is running, and again, that's now, once the data's up there, it's retrieving the latest value at a set number, and we're saying, look, is there smoke? It's red if there is, and if there isn't, we're going to use the weather. And that is that.